Hi and welcome to the fourth section of this video course. In this video course we'll be talking about lambdas and higher order functions. In this section you'll learn how to work with lambdas. We'll also see what are function types and how functions can be passed to another function. And we'll explore Kotlin standard library and see how extensively it uses function types. And finally, we'll also talk about receiver functions, which are a special kind of lambda. And this first video will be all about lambdas. And in this video, you'll learn how to declare lambdas and how lambdas can work as parameters. And we'll explain the function types, and we'll also see how functions can return other functions and can receive functions as parameters. So before we start explaining lambdas, let's take a look at what kind of problems do they solve. Let's pretend that Kotlin does not have lambdas and we want to do something trivial like filtering a list of items. So we defined one data class here and we have a list of items. It's a generic list that contains a list of cars. And if we want to make our code extensible, we would do something like this. We would define a functional interface or a single method interface that accepts as a parameter our type, our car type, and returns a boolean value. The function returns a boolean value if some kind of predicate filter matches on this car. The next step would be to define another method that iterates over all of the items in the list, applies this interface or the method inside the interface, and if boolean condition matches, it returns it to it adds it to the resulting list and then returns the result. And then when you have to call this method, you would provide an anonymous instance of this class where you specify the filter function. And as you can see here, that's a lot of code for doing something trivial. But thankfully Kotlin has full support for lambdas, and this would be the equivalent of the previous file. And a filter function is an extension function that comes with standard library, and we'll talk more about them in one of the upcoming videos. We'll see that Kotlin standard library is loaded with loads of functions that operate Java collections, and we'll take a look at most commonly used ones. And if you haven't seen lambdas before, this is a lambda. It's always enclosed inside of a curly brace, and lambdas could be explained as small chunks of code that can be passed to another function. So let's take a look at filter method inside of the Kotlin standard library. So if you install the Kotlin plugin, you can navigate to any method inside of your IDE, and we can see that filter function accepts a predicate. And we'll talk about the syntax of this in one of the upcoming videos where we talk about function types. And we can read this as a function, generic function that returns a boolean value. And instead of providing a real function, we can replace this with lambda. And as we can see, this is a syntax of lambda. And a syntax for lambda goes like this. First, you specify your type parameter, then comes the arrow, same as in Java 8, and then comes the lambda expression. And from this example, we can notice two things: that lambdas have full support for type inference. We haven't specified the type car here, and the compiler knows this, infers this, because we're operating on a generic list of cars. But let's just add car type, and we can see that the effect again is the same. And we're also missing a return statement, because this lambda accepts, actually a function type accepts a boolean return value, and again compiler knows this, so we don't have to specify the return statement, and this is our boolean expression that we're returning. And from this second example, you can observe that Kotlin allows you to place your function types, actually lambdas, outside of a function call. And in this example, we can see that lambdas can also capture local function variables. And in this method, we've defined one function variable, and a lambda here is defined in its own scope, but it can access types actually variables defined in some other scope. Actually, we can say it closes over this variable. And not only it can access them, it can also modify them, and Kotlin does not have a final keyword like Java has. And in Java, this would have to be a final variable, or if as a method parameter, it would have to be declared final keyword. And we can also see in the last example that you can use lambdas in Kotlin to define or create Java functional interfaces. And Java functional interfaces are actually a single method interfaces, like the well-known runnable example. And you can see here that we're creating a runnable with a lambda, and the only thing that's needed is to append the name of the interface before the lambda expression. So for example, if I remove the name, you'll see that I cannot create a runnable interface because compiler in this case cannot infer. And that's it for lambdas. We'll see more of them in action, especially when we start writing Android code. And before we finish, we just have to mention or explain how they're implemented on Kotlin. And since Kotlin targets Java 6 bytecode, which does not have support for lambdas, whenever you define a lambda in Kotlin, a compiler will generate a bytecode for creating an anonymous inner class. So there's a slight overhead for each lambda you create, but if you're on Android, in either case you will have to use anonymous inner class, so there's not much difference in terms of the overhead, but you get nicer and cleaner syntax. Okay, that's it for lambdas.